All right, we're going to get started real soon. So if everyone can grab a seat, I'm going to introduce Kegan, who will be your awesome instructor for this session. Cool. So Kegan has been working with the city of Santa Monica since before Obama's first term, and he's still finding new things to hack on. In his current role as the city's data officer, Kegan oversees Santa Monica's open data and open source publications. He also works on regional transit and mobility issues, staff education and skill building, and organizes Hack for LA's West Side Hack Night on Mondays in Santa Monica. Yay, Kegan. Yes. So, take it away.
Thank you, Nina. Thanks for welcoming me. Thanks for being here, everyone. So yeah, Nina gave the rundown. I don't need to go into too much of my history or anything. How many of you work for a local government? Mostly city of LA, or I heard Long Beach. Anybody else? LA County? Okay, that's great. So you're all maybe experiencing some of the issues that we're going to talk about today. Who works for central IT or whatever you call it in your agency? Who works with central IT or wishes you worked with them maybe a little bit more? Okay, so we have the common issue of, sometimes we don't get to decide what our operating systems are at work, what machines we're given, what tools we have. Are we programmers, system analysts, developers? What do you call yourselves? Data analysts? Do we write code? Does anybody write code? Okay. Command line, or are you more like Visual Studio, .NET, Python? What's your experience? Shout it out. Python, lots of Python. C#. Okay. So all over the place. All over the place. That's great. So we're going to be talking about better dev environments for free, and that didn't show up in the agenda, the for free. I just want to make a note. Who saw that list of requirements for pre-installing all this software? So it's definitely not free, right? It takes a massive amount of time. Did anybody get through that entire list? Everything fully installed? Most of it. Who has Docker, some version of Docker installed? Who does not have some version of Docker installed? Okay, so we have some helpers here. Hunter's going to be running around. Yeah, he'll be back around. We're going to be focusing on Docker today, using Docker as the container system, and we'll talk a little bit about what containers are. I don't want to spend too much time on theory, the differences between containers and virtual machines, things like that. Have you heard of Docker, heard of containers? Yes? Okay, so maybe I won't go too much into that. Just quickly throw up Docker's own documentation here. I think it's a nice way to kind of get it in your head, a little bit of the basics of what a container is. So we're all fairly familiar with virtual machines, hopefully virtual infrastructure. That's what we see on the right. A virtual machine, of course, it packages the operating system, any of the applications, the libraries, the binaries, pretty much everything you need. It's all in the virtual machine. And that's great. It allows central IT to reuse resources, maybe provision desktops for users or provision applications. But there's a bit of overhead with stuffing everything into the virtual machine, right? The full OS, all the application, all the binaries, everything. Where a container is slightly different. Similarly, it packages up applications and software and binaries and the needed dependencies. Really, containers are focused on the runtime, the application, what it needs to run, what it needs to execute, the environment variables, the configuration, connection strings, the code itself, all that. So we're going to look at how to create some containerized applications. We're going to start basically from nothing and build it up. So I hope that's okay with everyone. We're going to use the command line a bit and a text editor. So not too much that you need besides Docker. So if you don't have Docker installed, raise your hand again if you don't have Docker installed. It's okay. It's totally, it's not an easy thing to get going. It's okay. Are we Windows people or Mac people or something different if you don't have Docker installed? Windows. No, that's perfect. I'm on Windows. Look at me. I'm on Windows too. That was the plan. No shame there at all. And that's really, one of the great things about why we want to use Docker, why we want to use containers. As I mentioned before, most of us work for some kind of agency, some kind of company that tells us what our development environment is, right? They tell us what our OS is because it's managed by central IT or something else. But the nice thing about Docker and the nice thing about containers is it doesn't really matter what our machine is. We can run whatever code we want, whatever applications we want. Anybody ever tried to install Postgres on a Windows machine or get Ruby running on a Windows machine? Anything like all the new cool stuff that everyone uses, machine learning, Python, Ruby, Postgres, PostGIS, all this cool stuff.
Wake up with a Fortran compiler trying to run on Windows, and then you decide, well, I'm not doing this project.
Yeah, I mean, it's sad to say, but us Windows folks kind of get left in the dust with all this cool new stuff that's out there, these options that are out there for development. Not to say that the C# stuff is bad. I do C# stuff all the time, .NET stuff all the time, and it works for a lot of things. But when you want to try something new, when you want to, I don't know, investigate a new database system or play around with GIS if you've never done that before, it can be hard, right? It can be hard to get that environment spin up. And then
who has not been able to set up a new person on their team with their development? How long does it take you to onboard a new person on their team to their development environment? 6 days? 6 hours? 6 hours. It's pretty relative. Anybody else? Get all the connections figured out, set up a new server. It's a manual process, right? It takes you. One of the joys of Docker is your configuration, all those details about how this application runs in production, development, staging, testing. That weird environment you set up for this one person is code now.
Yes.
So I think that's yeah.
Yes. Yes. We oftentimes work in teams, and it's not enough to say, well, it runs on my machine, right? That we've all heard that, we've maybe used that before, but that only works as long as you're only working by yourself and you're never going to take anything into production. Yeah, that describes us here today, but maybe not when you go back to your desk at work, right? We need to work with other people. We need to share our code, work on teams, share our analysis, and then we need to ultimately run that code in a production environment. And going between all those machines, all those environments, that can be a pain. And so Docker and containers are really going to help us deal with that in a nice, consistent way, as Hunter mentioned, packaging up everything we need for the application to run. So that's about it in terms of the speaking portion of this, the non-content portion of this. And I just want to jump directly into the coding and get into Docker. So if you don't have Docker installed, maybe we'll take a few minutes. Is that possible to get it installed in a few minutes? Maybe. Did everybody see the installation instructions? I think, or you can pair up. Yeah, it should be relatively quick depending on your setup. If you're Windows, Docker won't install on older versions of Windows. Let's see. What do I have right now?
Raise your hand if you do have it installed.
Yeah, it might work.
Yeah.
Yeah.
So
Yeah. So I'm on Windows 10 Pro version 1803, and it definitely works for this version. But if you're on a version less than 1803, it might not work. There's this whole thing called Docker Toolkit or Tool Package or something like that, which is supposed to work on other versions of Windows. Unfortunately, we don't have the time to go through all these different versions. And I know I just talked about that's why we use Docker, right? So again, for free, because once you get Docker installed, which is a non-trivial task, then all this other stuff becomes easy. But getting that initial installation going maybe can be a challenge. So maybe pair up or just follow along. I don't really have
If you get super stuck, raise your hand. I'll come around.
Yeah.
Yeah.
And what we're going to put together today, again, I'm just going to start from scratch. I'm here in a empty folder. I'll put it online, send it out to you guys as at least this README file that I have, the scripts that we come up with, everything like that. So if you want to try it later, we can do that. Okay. All right. So let's just get our hands dirty with Docker. So I'm here in Visual Studio Code. I don't know if you're using that or another text editor. Shouldn't really matter. We're going to need a text editor, IDE, and then some kind of command line interface. And if you are a Windows person, you're probably maybe not used to the command. Who uses the command line on Windows? Anybody? Do you use CMD or something else? PowerShell or Bash? Great. So I'm going to be using Bash, which comes with Git for Windows. I'm not going to do a Git talk here, but Git for Windows is another package you can install fairly easily on Windows that does come with a Bash interpreter. So I'm going to use Bash. I don't think the Docker commands really care what shell you're using, so it should be more or less the same. But that being said, raise your hand if you're seeing some error output that I'm not showing or something like that. So I'm here in a basically an empty directory that I've called containers, and we want to just get started with Docker. And again, we're going to be doing this on the command line. So first things first is, can we just see, do we have Docker installed? And if I just type Docker and hit enter, it should print out some basic information, some usage information about what Docker is, right? And so I'm not going to go through all of these commands. There's fairly good documentation online. That's maybe a true statement, maybe not. Documentation varies, but we're not going to go through all this. We'll talk about some of the important ones today. But essentially, if you type Docker and then the command, like Docker run, for example, there's the usage for that command, and we can ask for help, like Docker run -- help. And there's some options for that command. So again, we're not going to go through all this. We'll just talk about a few different commands here. Okay, so we verified we have Docker installed. And how about what version do we have? So if I type Docker version, I have 18.09.1. Anybody have something massively different than that? Okay, that's good. You also notice at the bottom here, there's this weird error message, error during connect. Did anybody get that? So that probably means you don't have the Docker daemon running. So Docker is kind of this, again, going back to the what is Docker versus a virtual machine. Over here on the left side, we've got this Docker layer that sits on top of our operating system. And this is called the Docker daemon. And this is kind of a similar job that the hypervisor does for a VM. It talks to your operating system, allows Docker to exchange information between your operating system and the containers that are running. So we need to actually have that Docker daemon running in order for things to work. So if you have Docker installed on Windows, you should have this cute little whale icon, Docker for Windows. Maybe if you have a Finder, or if you're on Mac, you can just type Docker and it should have like a Docker desktop, something like that. So just start that guy up. And it does take a few seconds. There's a little icon here indicating that it's starting. The other thing that I'm going to be using quite a bit here in Visual Studio Code is a Docker plugin that comes with Visual Studio Code. So if you're on Visual Studio Code, I highly recommend getting this plugin. It's basically going to show us information about the containers we have, which ones are running, which ones are shut down, allow us to get some information about them. So all of this is available on the command line. It's totally possible to run commands to do this, but sometimes it's nice to see a visual indication of what's going on. I like to go back and forth. So if you're on Visual Studio Code, you might want to check out that Docker plugin. Okay, so did it start yet? Okay, it started, great. So if I do Docker version again, I should not get that error message at the bottom. Good, so we're running. Okay, so let's start. So Docker's all about containers, and we can run containers, we can build our own containers, which we'll be doing in a moment. But the other great thing about Docker is the community behind it, and there's a lot of kind of pre-published containers out there for doing various things that you might want to do, and we're going to use a lot of them today. But let's just start with the easy one, hello world, right? So this is just straight from the Docker tutorial, by the way. If you type Docker run hello-world. So we're telling our local Docker to run a container called hello world. Well, where is this container coming from? Well, we don't actually have it locally, as Docker says, unable to find it locally. So it's going to download it for us from the cloud, whatever. And you can see there's some status information. We downloaded an image, and then it printed some output. So we actually just downloaded a container, ran it, saw its output, and it closed. And that was the entire life cycle of the container. Who's started a VM before and kind of had to wait for it to start, and then it finally starts, and you have to log into it, and then you have to run your program. So we just did all of that in one command. It started, it downloaded it, it started it, it ran the program, printed the output, closed it down, deleted the container in seconds. Now this is a simple container, right? It's just printing a hello world message. But that's one of the huge benefits of Docker and containers in general, right? Is they're extremely quick to spin up, spin down, try things. So it's a nice way to explore as a developer or as a programmer, data analyst, something like that. Gives you a nice way to, again, reduce that overhead to trying something new, exploring something. So we just ran the hello world and we got some output. Anybody not get that output? What did you get? Did you see an error message? Oh, so that probably means the, what's that? Username and password error? Yeah. Ooh.
If you had issues, Bill and I are going to be coming around. Just kind of raising hands and flag it.
So it could be that the shell is not running under the appropriate user account. I'm not, yeah, that's a weird one. Could, yeah. So if you run your shell as administrator, maybe that's a fix for that one. And by the way, I don't have so much content, hopefully, that it's okay if we kind of go slowly through this, work out the bugs. That's kind of the plan here. So definitely raise your hand if you have questions or if you're not seeing something that I'm showing. We want to make sure it makes sense. Because, by the way, John's over there, Ian's over there, Will's walking around. These guys are going to get really hardcore with Jupyter notebooks, Python, analyzing GIS data, all this stuff. So this is kind of the slow intro to that, hopefully, because later this afternoon and tomorrow is going to be intense.
Just as a follower.
Yeah.
I've tried working with just virtual ENV instead, and sort of you talk about the pros and cons with doing that in Docker.
Yeah, that's a great thing to talk about. So virtual ENV or a virtual kind of package, virtual environment, I guess. Yeah, virtual environment. Python, to an extent, Node, Ruby, a lot of these kind of newer scripting-based interpreted languages, they have this concept of environments. And so an environment is where we have a particular version or versions of libraries that we need installed. And this can really be a problem, especially if you're doing local development where you have one project that needs version 10 of a library and then another project that needs version 12 of that library. Well, if you have version 10 installed on your machine, can you also install version 12? And can you tell your application which one to use? And what if they, step on each other's toes? So that's what a virtual environment gets around, is it helps you isolate just the installation of and the use of different versions of the libraries you're using. So a container, Docker, very similar to that concept where we're packaging up a specific version of library that we need, but it goes a little bit further than just the dependencies that we have, the library dependencies, to encompass things like all the configuration information that we need. So things like database passwords, those kinds of things. So the container is really a self-contained, 100% self-contained package that you should theoretically be able to create on your machine, pick it up, drop it on somebody else's machine, and it just works. Versus a virtual environment, maybe you have to create it, and then somebody else has to create it, and then replicate that and make sure you've got it the same. The container kind of takes care of that for you. As long as you have the container, you just hand it to somebody else and they run it. So at the bottom of this hello world message, there was a little message, try something more ambitious. So for you Windows folks, even for the Mac folks, getting an Ubuntu VM running, that's a download. That ISO is like a couple gigabytes, right? That takes a while. You know, there's some setup there. Well, with Docker, we can just say Docker run. I'm going to hopefully not misspell things today. We can just say Docker run, and we're going to add some options here, and I'll talk about that in a second. So we're going to ask Docker to run an Ubuntu container for us, and this IT option says make it interactive. So I want to log into this container, and I want to log in to a bash prompt in the container. And of course, I don't have this locally, so it's going to download it from the internet, and this wasn't really something I was counting on. I hope the connection speed is pretty good here, and we're not all clobbering each other trying to download things at the same time. This is probably the largest VM or container that we're going to download. So if this takes a long time, we'll just skip it. And it seems like it's taking a really long time. Yeah, okay, I'm just going to skip this. So sometimes containers do take a while to download, but the whole thing is once you download it, and just referencing back to the Visual Studio plugin that I was talking about, I have in my list of images right here that I've downloaded the Hello World image that we ran earlier. And so an image, we talked about containers, right? An image you could think of as it's the source code or the compiled version of the source code. And a container is a running instance of that image, okay? So we got the image for Hello World, and we can run it as many times as we need with those commands, or here in Visual Studio, I can right-click and say run, and it does the same thing that we saw before. So the image is the runnable thing, and the container is the running instance of that thing. So the Ubuntu container or the Ubuntu image was a little too big. We're not going to worry about that. But let's actually just jump into creating our own, because that's a little bit more fun.
So one cool thing to touch on before we go to like containers is once you have a working container, like you have a new version of your app, you've built that image, and let's say you're trying to deploy it, you can then just push it to, you push like the entire image to your container infrastructure somewhere, whether it's on-prem or on the cloud. Your production is actually not just taking the code. Typically, your production, your dev to test a production is about pushing just the code itself, code changes. Right. This is actually taking the entire thing you need to run your application, just how it was working locally, onto the production servers, which is a little weird to think about because you've built an image like, oh, this image worked locally as a container. I'm going to make this image work in production as a container. But it's really powerful because then you can actually test that everything is running and your infrastructure works exactly as is. And it makes the cost of deploying your application vastly lower. Yeah. You make the cost of your deploying, like, who has like a long deploy checklist or has worked on applications where you had like many steps to deploy and like you maybe did, how often did you release those applications? Yeah. Like, would you do a monthly release or? Yeah. Yeah, like so where it's like everything gets bundled up into a monthly release and like things can go wrong when you do that a lot because it's so many changes at once. You never know, like, oh, it turns out like I had one where we had a monthly release and we didn't notice that we had a migration. It was Python application and we had schema changes using a pretty standard library for tracking schema changes in Python. But we had both developers, myself and another developer, had created a migrations file with the exact same name. So we had two migrations, the same thing. We broke the application in production. Big disaster. We were down for like a day and a half until we figured this out. Yeah. But if you can just push the image, suddenly the cost of deploying is like almost nothing. So it's very hard to break your applications in production or your pipelines in production because the cost of moving your changes, you can move smaller changes that are easy to roll back. And let's say by some like disaster, it broke in production, like you didn't count for something, like there is weirdness. This doesn't totally eliminate it. Is like when the cost of doing something is lower, you can do it more frequently. And that means things are less likely to go wrong. Yeah. So if like, oh, I made something wrong. Oh, let me just pull the old image instead of the one, last working image. Go back. Rollbacks are super easy. So that's like this does seem like a lot of overhead sometimes. It's like, why am I pushing? I just need the code. I don't need the entire like operating system for something. But there's actually a good reason why you do actually need the entire operating system.
Yeah, and totally relevant. And yeah, I think, one way to think about it is we're not deploying the executable. We're not deploying the exe file that runs our code. We're deploying everything. It contains the exe file, all the libraries it needs, the entire package, and that's what the image is. So yeah, let's just start developing one, and maybe it'll start connecting to the dots a little bit more. So I'm gonna just create a directory here called Python, and because we're gonna be working in Python, so I'll jump into there. And in Docker, we have this concept of a Docker file, and this is like a recipe file for how to build an image. So I'm going to create a Docker file, and for Windows folks, don't be scared. There's no extension here. It's just called Docker file. No dot anything. It's just Docker file, and it works. It works. Okay, so all I did was I created this file. I created a folder called Python, and then inside that folder, I created a file called Docker file. And this is an empty file right now, but we're going to start with. The nice thing about containers, the nice thing about Docker is it's built in this concept called layers, and we can build containers on top of other containers. So we're going to start with, believe it or not, a Python container. There's a Python container that just exists. You can say from Python, and even the version that you want. We want version 3 here. We could even say version 3.6. We'll just stick with version 3. So we've created this Docker file, and we're saying that it's going to create an image that's based on the Python 3 image. And that's all this Docker file says so far. Okay, so if you have that saved and you're in the directory with the Docker file, we can build it. So we can say Docker build, and I'll use the T parameter to give it a tag. And I've been using this sod pi, which is a little strange, but School of Data pi. And we'll go ahead and version it at version 0. So this gets directly into what Hunter was just talking about. When you're in the world of containers and things are very easy to change and rapidly change, you can create versions and very easily jump back and forth between versions. So you'll see what I mean. When I build this at version 0, and by the way, we need one last parameter, and that's the directory that contains the Docker file, which is dot, the current directory. Hit enter. So it's going to build from the Python, and you can see it's doing the steps there from Python 3, and it's going to download it. This hopefully won't take as long. It's a pretty lightweight container. And again, this is only a one-time download. Once we have Python locally, we can build and rebuild and spin up different versions of this much more quickly. So I tagged it at version 0 because we're going to go through a couple different changes of this Docker file and the container that we're building. But at any point, we can always spin up a previous version and see what things looked like back then. And creating new versions doesn't necessarily clobber the old ones. And so when I say old version of a container, remember, it's the code, it's the configuration, the environment variables, the ports we've opened, all the different things that we need to do for our application is going to be packaged up in that container. So this is downloading. And again, we'll see on this list here eventually a Python 3 image that will get built. And then we'll see the image that we're building right now, which we've called sodpy at version 0. So everybody getting this download, it's taking a little while, but it's working, or you're just watching me do it. Of course, I had this working. I just wanted to delete everything and start from scratch so I could be in your boat. Didn't think about the connection issue though, or the slow, or it's not that slow. Oh, well, that seems really slow.
So just for clarity, let's say we wanted to take this Python library and then deploy like sort of 2 different versions. We could build on top of this one we downloaded and have one that's got like one set of libraries.
Absolutely.
And then another one for
Yep.
another set.
Yep.
You never have to download Python again, or.
That's right. Yeah.
Yeah. So often, like what I'm working on for my team right now is like we just have a standard, like we have a base image that we version of like all the things we might need for our team to work off of, and then each project gets its own specific one that inherits from that base image. So you're like, here's the standard stuff, so you don't have to like constantly be copying and pasting like apt-get install Postgres, pip install pandas. Like that's all in one central one. And then like the specific one, like when we're working on like mobility data projects, where you have one that says like install the specific one, like the specific like geofencing, whatever, like that's like when we're working on track.
It's another huge benefit of going the route of containers, because as I mentioned before, they're all built on this concept of layers. So at the bottom of that stack, you can have everything you need that you think you're going to need for all future projects, right? Imagine you're a big data science team. You've got all your standard packages that everyone's going to need, and then you're going to do this project and that project and that project. And everybody can make use of that on the team. And at some point, if you need to, you can update that base. If you need to install a new package that everyone needs or upgrade a version or whatever, and then everybody can just repull it, rebuild their own projects on top of that, and it all just kind of flows in. So yeah, it's a nice way to kind of build components and deal with this issue of downloading images, which does take some time once in a while. Yeah, I think so. Is that better? Oh yeah, sorry. So this is the command we ran to download Python, or to build our Docker file. Docker build with the tag sodpy version 0 and then dot. Notice we're inside the Python folder that we created, which has this Docker file inside it.
Hey, Kegan, I'm over here. Hey,
Okay.
I was just going to ask while we're waiting,
Yeah.
Where do these images come from? What magic place do they come
What
from?
magic place on the internet do they come from? Yeah, that's a good question. So Docker runs something called the Docker Hub, and this is one place that they come from. So who's heard of GitHub? Semi-familiar with that? Place where you store code and data and stuff like that. Similar to that, Docker Hub is a place where people can publish their Docker files that they've written. So by default, when you just say, install Python 3 or something like that, it's actually going up to Docker Hub, and we can control-click to follow that link. I think it'll take us to the internet. Yeah, so it's actually on Docker Hub. Python has created this official Python Docker image, and we can look at this. We can look at, here's the installation instructions and all the versions they have and all the tags, and here's the quick reference. So it's similar to GitHub in that it's a place to publish and share these Docker files. Now, Docker Hub is not the only container registry. I'm not exactly sure what the terminology is for this. You can create your own. So you can have an internal container registry where your team is sharing, your standard data science or whatever it is, your web applications or whatever containers. You can create these on AWS, Azure. So a lot of the cloud service providers have container registries built into them. I think, Will, you're going to talk about using the AWS container registry, right? Yeah. So a lot of the public ones are on Docker Hub, but then there's many other container registries out there, and then you can create your own as an organization if you need to. Right. Yeah. So what we're downloading now is probably built on some version of Linux. And then there's all the Python stuff that needs to get installed, all that headache that maybe you went through installing Python on your system or didn't want to go through. Somebody's done that for us and packaged it up as a Docker container. So yeah, it's not just that we're downloading, it's not the same as going to python.org and downloading Python. We're actually downloading an OS that has Python installed, that has everything packaged up for us. So yeah, it is a little bit more than just. Right. And you can always dig into where exactly this stuff is coming from. So for example, here we are on the Python one, and if we look at I think it shows us the Docker file. Maybe not, but some of these ones, they'll actually print the Docker file that created this container, and they all start from somewhere. So there's always going to be this from something at the top of the Docker file. And so it's just this giant stack of, at the very bottom or top of the stack, however you look at it, is like some version of Linux, you know, at the end of the day, and probably some really small version that doesn't have a whole lot going on. And then you just install Python, install this library, install that library. That's right. Yep. It's not quite Ubuntu, but it's a Linux operating system. Yeah. Probably not as full featured as Ubuntu. It doesn't have all the, for example, it doesn't have a web browser. It doesn't have a graphical interface. It doesn't have, you know, applications that you might use. It's just the bare bones stuff. Because really all we need is an execution environment for our Python code. And that's what we're getting. Assuming it downloads. Yeah.
So what would you do if there are issues where you have to patch the OS? Do we download that or?
So typically, if we're consuming the Python, you know, the Python base container here, for example, we don't really have to worry about upgrading the operating system. When we're working in containers, we're focused on our applications, right?
Is there, let's say there is a vulnerability,
Mhm.
whatever that is based on,
Mm-hmm.
what would you do?
Right. So you can, I mean, theoretically and hopefully whoever created the container, like the Python one here, is watching that stuff and maintaining it, and they're updating their lower level dependencies. And then you can always pull the latest version, right? So if an update has been made to Python here, and if I'm just going back to this web page, you can see all these versions that they've published, and I can get any of these versions. Like, let's say the tags here. So 19 hours ago, they posted an update. So this is constantly being updated, and I can always, sorry, it's a little hard to see. So there's all these different versions that I can ask for, and we just asked for version 3, but these things are constantly getting updated with patches and whatever. So if you need to, you can always just pull the latest version. And you're not in the mode of like, oh, I have to log into the OS and update this patch and update that patch necessarily. You can be in that mode.
But let's say like you already have the container or you already have the image.
Yep.
And is it standard practice to go in and download the latest one, or?
I don't know if there's a standard practice. Yeah, I think certainly if you're running some production code that absolutely must be 100% up to date all the time, 100% secure, latest patches, there's ways to build this into your pipeline, right? Hunter was talking about when the stuff is lightweight enough, you can deploy changes a lot in your continuous delivery, CD, CI, familiar with that concept. So you can build that into your CD, CI pipeline to say, every time I make a change, for example, go get the very latest version of everything, rebuild everything, and then deploy it. So it's certainly possible. But again, there's different modes, right? So right now we're just kind of like experimenting and trying things out. And so we wouldn't really be worried about, well, we got to update Python every time, because I mean, it changed 19 hours ago, but it probably won't change in the course of the next hour, right? So are we still downloading here? Yeah.
You could SSH too.
Not on this computer. Oh, now it's going really fast. Any other questions as we're waiting here about just kind of what we're talking about? Yeah. Yeah, absolutely. So I am on, here it is. So Windows 10 Pro 64-bit version 1803. And I think, so let me see if I can pull up our install instructions. I think there's a minimum version of Windows. Let me just, since we're waiting anyway, might as well pull this up. Not the schedule. Where's the install? Anybody have that install document handy? I wrote on there. What's the minimum version of Windows? 1703 something? Okay, so 1607. If you're lower than 1607 here, the standard Docker Community Edition probably won't work for you. And in that document, there's a link to Docker Toolkit, which is supposed to be for older versions of Windows. Whichever one you picked, the commands still should be the same. So it still should work. This top one is just killing us here. I know. Well, let's start writing code, and then maybe while we're writing that, this thing will finish, and then we can keep going. So I'm going to create a Python file. Just call it main.py. And again, I think I do have it installed on my computer, but we haven't talked about installing Python or getting the library dependencies or anything like that. So theoretically, if I write this code right now, it won't even run on my development machine because I theoretically don't even have Python installed right now. Pretend this is a brand new laptop. I just installed Docker and I don't have Python installed. So I'm writing Python code that I can't even run on my development machine, right? And maybe that's your case at work or maybe not. But the whole point is we should be able to run it inside a container that has all those dependencies and everything we need. And so that's what we'll be doing. If you're familiar with Python, you're familiar with the import statement, bringing in libraries. If you're not, if you're familiar with something like C#, this is similar to a using statement. JavaScript, they all pretty much have this concept of bringing in external libraries. So we're going to use a popular library, pretty popular library called Pandas. Anybody heard of that one? Pandas. So yeah, it's all about data science, working with data, analyzing data. We're not going to do a whole lot. The point here is to illustrate using Pandas from a machine that's not configured to use Pandas. So we'll import it, even though I don't necessarily have it. Pretend that you didn't see that. And we're going to download some data from the internet. So I put this out there on our website. And this is some inspections data from our building and safety permit inspections that they do. So they go out to, make sure that the permit is valid, I guess. I'm not a building inspector. I don't know what they do. Talk to your people. Understand the data before you start analyzing it. You could download this file directly if you wanted to check it out. It's just a CSV file, although now that I'm thinking about it, it's probably 50 megs, so it's probably going to take half the day to download this. Maybe I'll just check this out. Yeah, we'll open it with Excel. So yeah, this is a kind of your standard information about permit inspections, nothing too interesting. The date, the permit number, this is from our open data portal, the address, the estimated inspection time, things like that. So we're going to write some Python code that downloads this and uses Pandas to load it into what's called a data frame, kind of like a table, if you will, and allows you to analyze and figure out different things about it. And then if we can get there, we will we'll open that and run that code in a notebook and then load that code into a Postgres database and then view that data in pgadmin. That's a lot to get through if none of this stuff downloads, but we'll go through it as much as we can.
So, but it's also capable of reading the local file.
Oh, absolutely. Yeah, exactly. Yeah. So anything, yeah, it could be a local file. We happen to use one on the internet just because you all don't have the same file, so it was an easy one. But yeah, this could be a local file as well. The point is, though, and it's important to remember this code is not going to be executing on our machine. So when we say local file, that doesn't mean a file that's on your laptop. That's a file that's in the container. That's where this code is going to be executing, inside the container. So whatever files you need, whatever, if it's data, if it's configuration, whatever it is, that needs to be in the container. And we'll see how to get it in there. We'll use the Docker file to copy files from our local machine into the container when we build it. We'll see that. So let's continue with this, just writing some code here really quickly. This is just really not a whole lot of code to write. So just printing just to make sure that we see what's going on. Okay, we'll download that. Right, so pandas allows us to create these things called data frames, and we can do that a number of ways. One of the ways is just to read a CSV file directly, and that URL happens to represent a CSV file, so I can pass the URL directly into the pandas read CSV function, and that'll give us back a data frame. And once we have a data frame, we can print some information about it. Maybe we want to know how many columns it has, and what are the types of the columns, and what are the names of those columns, how many rows does it have, that kind of thing. So a really simple thing to do is call the info method on a data frame, and we'll just print out what that shows us. And it's just going to give us some information about the data frame. So yeah, there it is. It telling me there? And then maybe we want to print, I don't know, the first 5 rows of data here. So the head, 5 rows, something like that. So once we have our Python environment downloaded, we can run this code. But again, I shouldn't be able to run this on my local machine because I probably haven't installed Python. I probably don't have pandas working. There's a lot of prereqs for pandas, NumPy, and all this other stuff. Are we almost there? Not quite. So you can see that's a fairly short amount of code to download some data into a data frame. It was pretty much just one line right there once you have your URL, or this could be a local file path. Pandas, Python in general, you probably know this if you're using it, allows you to do a lot with a little, which is really great. I'm by no means a pandas expert or even intermediate or even beginner. So if you have pandas questions, please don't ask me. Hunter, Ian, John, they're probably much better resources for that. So while we're waiting, the next step, of course, we have our code now, but we can't run it. We need to get it inside our container, right? And we started with this pretty simple Docker file where we just said we want to base our image on the Python 3 image, and we didn't do much else. Well, now let's start to expand and do some more work with this Docker file. So one of the things that's pretty common when you're working with Docker, but also just in general, is you want to know what directory you're working in, right? If we're inside this giant Linux VM or container or whatever, we don't know exactly where things are happening. We want to be explicit with what's the working directory that we're working, right? So in Docker, you can say, when a container starts, I want it to be in this particular working directory. And you can use the work dir, I don't know what these are called, attributes, commands, to specify that. So we'll just kind of use a standard Linux location for applications. And if you're not a Linux person like me, you probably don't even really know what this means. It doesn't matter. It's just a folder on the computer. All we're saying is we want our Docker code and our Docker container, when it starts up, we want it to be in that folder. And then,
You don't specify that because it just had its own default.
yeah, so it defaults to / which is kind of like the root of the container, right? And that's kind of where a Linux environment just starts, right, is the root. And then there's user folders under that and library folders and all that kind of stuff. So we're just saying, don't start at the root, start a couple folders down in this particular place. Yes, the working directory of the containers file system. So when we actually start this container up, and we'll see, when we log into the container, again, think of VM. You're starting up the VM and you're going to log into it. That's the folder we'll be in when we log in by default. And it's also the folder that other commands that we're going to write here in the Docker file act on by default. So for example, the first thing we want to do is copy our file in, right? We have our Python file. We need to copy that file from our local machine into the container. And so we use the copy command to do that. So we can say copy main.py. You can give it the name of the file you want to copy it to, or you can just say put it in the current directory. You can even say copy everything into the current directory. So there's lots of different ways to do this. I'm just going to copy this one file for now into the current directory. And so with these two changes, it should be enough for us, assuming all these downloads work, for us to start up this Python container. Well, first we have to build our image, right? We created this Docker file that says how to build an image. We have to build it, which we're waiting for right now, the first one. So we build it, which copies in our file. And then we'll be able to start up an instance, a container, and we can log into it on a bash prompt and see our file, run it as a Python file, whatever we need to do. And eventually we'll get to something like the hello world example where we didn't even log in. We just said, run this container hello world, and it did something and printed its output. So we can make our own containers, kind of executable containers, as they call them, where it's not, you're not using the container as an environment that you're logging into and you've got a command line and all that stuff. You're using it as the application itself. Yes. Here's the Python script. Let me just minimize this. So there it is, all 11 lines of glory. Oh, we've got some movement here. Things are looking good. Ooh, hey, it worked. We have our first built image from our Docker file. So remember, this was before we made all these changes just now. This was version 0 when we just started from this one. So now we have it built, and if you don't have it built, just follow along. It'll get there eventually. So we can actually run it. And so I'll open up my little Docker Explorer here, and you'll see that not only do I have the Python 3 image now, which we based ours on, but we also have our SodPy at version 0 image that was based on this Python 3. So I've got this running list of images, and at any time I can go and say, oh, I want this version or that version, inspect it, push it up to my container registry so I can share it with other people, remove it, you know, do various things. So these images, again, are kind of the compiled version, and then we can run them as containers. So let's do that. We've got our SodPy version 0 here. So I'm just going to Docker run. Let me just verify my notes here. Right. So one thing to watch out for. Remember, we want to run it in interactive mode. If I just say run the name of the container without the version, it doesn't know which one I'm talking about. We don't have, by default, Docker is going to look for a version called latest. We didn't specify a version called latest. We specified a version called 0. So it doesn't know what to do. That's okay. We just need to tell it what version we want to run. If we run that, what happened? We got a Python prompt. So by default, the Python container, when you just start it up, it puts you in a Python prompt. And this is, you know, this is standard Python. We could do things like print hello. There it is. Anything Python you want to do, import, I don't know, JSON, do some stuff. Yeah. Whatever you need to do. You're in Python right here. So that's nice, but again, we don't want to just be logging into containers and manually running typing things. We want to actually run our own programs, right? So I'm just going to get out of that. Go ahead.
Before you exit, I want to just run that again.
See how quickly that was? I just exited and jumped right back in. Took seconds.
Where do you think we are right now? Like, what's the current working directory?
Remember, we haven't made these changes yet.
Yeah, so what this has access to, what is going on, you import OS
Yeah.
and type os.getcwd, I want to say. Let's see if I remember. We are on, in Windows, there's an entire Linux subsystem with Linux paths, Linux file types, like all the normal things to like run Python the same way. So if you like run Python on Windows and worked on Python on Windows environments, which I've done for a long time, how many times you get like, you have the wrong file ending, like the wrong encoding, like this is a constant hassle. Like, and this, you know, yeah, it takes a while to download, and especially when you are all hitting the same Wi-Fi network in a tutorial session. But like, this is sort of radical that this has just got, oh, this is a machine that is inside the machine. So it's like,
Just real quick, and you're doing a great job. Just stop right, pause.
all right.
So it is noon right now. At 12:30, lunch will be served. Lunch is gonna be in the kitchen right here. We gotta basically get people that's packaged up, so it should go pretty quickly, but we gotta kind of get everybody a meal in a half hour, and then go into the whatever that big room we started in is, and get yourself set up and you can eat in there. And then we'll do a keynote at about, we'll do some more notes at 1 o'clock. So just wanted to give you guys set expectations for what's gonna happen. And since you're right next to the door, you guys are lucky because you can like get out of here and when the food's there, we'll let you know. So anyways, all right, unpause.
Thank you.
So that's just wanted to unpack that
Yes.
a little bit.
So this this Python environment, this Python interpreter that we're on right now is running inside the container. And we can see that the current working directory, because we haven't specified it, is root, the root of this Linux container. And we just saw that by that. So what if we didn't want to jump directly into the Python interpreter? Maybe we would just want to jump into the container itself and then execute Python ourselves. So we can do that. We can run our same container, but instead of the default, we're actually going to run bash. We want to jump into a bash prompt. So here we are. We're now, again, logged in as root to this container system that's 4.2, whatever, 4C2E5, might be something different for you. But I'm here in a full Linux environment that Docker spun up for me. And so there's the kind of Linux file system that you're used to, if you're used to that. And I've got Python available to me. I can start that up just like we had before. And this is essentially what the container did by default, is it started up into Python. But now we can do any other thing we need to do on Linux. And this is the same that we saw before with, or we would have seen before with the Ubuntu if it hadn't have taken forever to download. But we've got a full Linux environment here. So we can do Linux commands like SSH and all kinds of stuff like that, right? This is, again, a running container. And by the way, I'll just point to my list over here. So I've got the image that we built, SodPy0. And right here is this current running instance. You know it's running by this green dot. And so it's telling me that it's been up for about a minute. Here's some other ones that I started earlier and closed out of. But this is the one we're on right now, and we're running. And I can exit this. And then you'll notice that it shut down. So now it's stopped. What was that?
Well, so by default, containers have a command that they're going to run when you say Docker run. What command at the command prompt they're going to run. For the Python image, it defines in the Docker file that's defined from Python 3, that command is Python. But let's say you wanted to run bash, or you're trying to, especially for debugging, like you might want to use IPDB, PDB, Python's debugger. Like instead of specifying, you don't have to go to the vault, you don't have to build a new image. You can just override that at the command prompt by specifying what command you want to run as the last thing.
So here's another example. We could say run, like we showed before, we could jump directly into the bash prompt and we could do like a bash command there, right? Or again, I'm running a new version of this container. I want to run bash, but then I want to run a particular command and just get the output. Well, maybe I should do. So in this version of the run, we ran our Python container, we started bash, and we sent bash the command echo hello. And so it echoed hello, and the container dropped. So we just sent a command into the container, got the output back, and that was the entire life of the container. Now it's done. So by default, containers they're called the entry point, the place that the container starts, the program that the container starts. But you can override that by passing in, well, I want to run bash, or I want to run this program, maybe the program that I'm writing, I want to run that by default. So that's what we just did. Does that kind of answer your question?
You could.
Probably.
It can get very Russian nested, y'all.
Yeah.
Very quickly. This is actually a way you can get yourself kind of confused.
Yeah.
It's like a Docker container. The best practice is to use inheritance, where you build different so you might have a community started base image, which is really itself inheriting from a lot of things. So Python is a community started, but there's actually a Jupyter. What's the one we're using in the the Jupyter lab?
Yeah.
Right.
Paper mill?
Which image? Docker image.
Oh, Python 3.
Oh, you're starting with Python 3. Okay. But you could get a whole Jupyter.
We're going to look at some other Python images.
Yeah.
So assuming they download.
But you'd inherit different. So it's
yeah.
You might have the last image is just really the specific project, and it inherits from you have a shared team one that itself inherits from some community image. So using that from is better practice than running containers inside containers, because then you start Russian nesting. Yeah.
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 Typically, you want to be in this mode of your container is the smallest piece of your application possible. And if at all possible, you can break those into multiple pieces. Those are just all their own containers, right? We might have our web server in one container, our database server in another container, our business logic in another container, our data pipeline in another one, our validation in another one. So however you can logically break up your application, you can create a container for each of those. And we're not going to get into the whole container orchestration and how you spin up multiple and tear them down, but there's lots of ways to deal with that in a real production environment. And I think you might be talking a little bit about that tomorrow.
If I can add two quick things.
Please.
One is, I'm not an expert in this, but running containers inside containers is highly preferred for security. Yeah. So the other way to do it that's super convenient is using a utility package called Docker Compose.
Yeah.
Which does exactly this.
Yeah.
In a local sense. You can have Docker Compose,
And
spin them all up, and talk to each other.
yep.
And then when you deploy them, you're deploying them individually. Docker Compose is not meant for production.
Yeah.
But it's a way to.
So let's we have maybe 15 or so minutes left. Let's try and go really fast through actually running our code. So the first version of that container image we built didn't have our code in it, right? So now that we made the changes to the Docker file, I'm going to rebuild. So I want to Docker build. Again, I'm going to tag it with sodpy, new version 1. And I want to build what's currently in this directory. Now notice it didn't have to re-download Python that time. I already had Python. So thankfully, we don't have to wait around another 30 minutes for that to happen. It just took the changes that I made to my own Docker file. So it saw this from Python 3 before. And this is where that layering really comes in handy, is it's caching the layers. So it cached locally the layer Python 3, and we just added a couple layers on top of that. The work directory, and the copy image. And you can see that there's removing intermediate containers. So there's layers happening in the middle that are getting built. And then at the end, those intermediate ones are removed and we end up with our final one. So now over here on my list, you can see we've got a new version, sodpy 1. So let's run that one. And I'm just going to run the default. Sorry, if I run the default, it'll be a Python prompt, right? So let's run bash. So two things to notice. We're not in the root anymore. We're in user source app, which is coming from this work directory, right? We said we want our container to start in this work directory, and so we did. There we are. And if I check out what's in this directory, well, there's my file, main.py. And if I look at that file, make sure that it is in fact the code that we wrote. There's the import and all that stuff, right? So now we've got our file in our container, and we're in a Python container. So we should be able to run this code, right? We should be able to say Python main.py. That's how you run a script, right? Oh, pandas. We don't have pandas. So we have a Python container, but we didn't actually install the pandas library, right? So this is going back to the question about virtual environments and what's the difference. Well, now we have our code there, but the code that is running doesn't have the dependencies that it needs. So we need to get those dependencies inside the container as well. And when we're working with Python, we can use a couple different options, but one common option is a requirements file. So I'm going to create a requirements file. And I'll open that up. And a requirements file just allows you to list the libraries that you need. So in this case, we need pandas, so I'll just list pandas. And if you're familiar with Python, you've probably heard of pip, which allows you to install dependencies from a requirements file. So we need to do two things. We need to get that requirements file into our container. Just like we got the Python in there, we can get our requirements in there same way. So I'll just add that. So we're going to copy the Python file and the requirements file into the root. And once it's there, we need to do pip install, right? We need to run that installation against that requirements file. So Docker files have a nice command called run, which literally just sends a command into the container to run. So we're going to run pip install from that requirements file. And this is the same way you'd be doing it on your local machine. You know, you'd say run pip install our requirements right here. We're just sending that exact same command into the container as it's being built. So by the time it's built, the image is built, all of this has already happened. The pip is installed. So let's rebuild the container now. And we'll tag a different version. So I'm going to tag it at 2. Now notice, it's got this step 4, run pip install requirements. So now it's collecting pandas. So that's good. It got my requirements file with pandas, and it's going to download 10 megs over the next 25 minutes.
One thing to notice is that as you change your Docker file, it will always keep up to date every time you build with what is the latest thing you changed. It runs in the order. So if I had instead put run pip install our requirements.txt before work during copy, it would rebuild the image starting from Python 3. Right. So everything executes in the order that you put it in, and it's cached. If you change something upstream, it will rerun the command downstream. So if you change line 2, it will then rerun the commands in 3, 4, 5, so on and so forth.
Right.
So the advantage here is it caches as much as possible, which greatly speeds up. Like if you have to if you worked in virtual machines, like rebuilding virtual machines is a costly and time-consuming procedure. This means rebuilding images is fairly quick. Like once you've built most of your image, like each incremental change itself is pretty fast.
Right. So if you're still downloading the first one, then yeah, it wouldn't have completed yet.
Right. So the only thing that exists if you've only done from Python 3 is the stuff that's defined in the Python 3 Docker file, which you don't see, but like there's stuff going there. But to get our files from our project directory, we have to use the copy command.
Right.
So like typically what you'll want to see in a copy command is copy the entire working directory into wherever your working directory is inside Linux, which might be user source. So like typically you see something like user source app, and then you say copy dot into dot, which will say basically means copy everything from my my file path on my local machine into the image.
Right.
Yeah.
And it is important to point out that as we're making changes to the Docker file, we have to rebuild our image. And whether you're building it at the same version or a new version, it's not going to automatically pick up the changes of the Docker file if you just say Docker run, whatever. You need to rebuild it to say, hey, there's been a change to my Docker file, rebuild the new image. So if you're still waiting for that initial download and we've made these changes, then a run on that initial download will not include these changes. You'll need to make the changes, rebuild, and then run again. Kubernetes is running thousands of containers all together, orchestrating them all together. Yeah. Saw your hand. Yes, it's just a single line pandas.
Oh, yeah.
Yes.
One more thing, I don't know if you've heard this, but if you log into the Docker container and make changes and log out, those changes all disappear.
Yes. That's a good point.
It's just a gotcha. There are ways to get around it, but by default, any changes you're making in the container, after you log out, they totally disappear, and the container reverts back to the initial image.
Yeah.
This is actually a good thing, too.
Yes.
It seems like a pain, but this forces you to document the state of your application.
Going back to your talk on, I wish somebody would have documented who tracked the cell phone numbers and how that was tracked, because nobody knows how to do it. Well, the Docker file kind of documents exactly the steps to create the environment.
If it's in your version source control, then it's you typically source control using Git or Subversion or whatever, CDS, whatever you want to use, your Docker file.
Docker file is just a text file, right? Yeah. It's really easy to version in Git or something like that.
The reason why it's important is let's say you have some lines in your code, I typically have this, if my environment is dev, connect to the dev database at localhost or at some other org. If my environment is test, connect to the test database. My environment is prod, connect to the prod database. If you are me, you have sometimes maybe run your dev code on your production database because you forgot to export the ends properly. It just happened. But with Docker, you're forced to articulate what that is into the state, so you don't actually run code in dev as if it was against your production database. And this is where Docker Compose comes in about orchestrating, there's a database layer, there's a API layer, there's a front end layer or whatever, with many different Docker files for each layer.
Okay, so we rebuilt. The pandas install finally finished. And we've got a new version here, SodPy 2. So we can run that again. And again, I'll jump into Bash. And, oh, sorry, I just ran SodPy 1. See that? This is where versions are cool. I ran version 1 before we did the requirements install, before we did the Panda stuff. So the requirements file isn't even there. You can see I did ls, there's no requirements file. But if I exit and run version 2, which we just recreated, there's the requirements file. And now Python should be able to import pandas, right? Okay, great, it's working. So now we should be able to finally run our code, right? Hey, remember our little script here? Downloading data, then it's going to read it in as a CSV, it's going to print some info, and then it's going to print the first 5 rows.
Oh, it's a small data set.
So it's just a name, a friendly name given to the container. So all these containers, the runs, they have these really random IDs, right? So you can let Docker give it a friendly-ish name, or you can give it a name yourself. It's just a way to identify this container's that one, this one's that one. If you don't say, name it this, then Docker just comes up with this really, adjective underscore noun thing, which is really weird, right? Dreamy Hellman, Serene Wozniak. Yeah, there's just all kinds of random things here. So
Do you maybe want to show what this looks like in a project? Because I think people know that this is going to run and work.
yeah, like a
Just kind of a tour of what you do with provider services.
Sure.
Just kind of roll through.
Sure. Yeah.
Yeah, so you should, you'll need to rebuild. So typically you'll make a little, but you have to build again. And this is why we use the latest tag often rather than versioning every time.
Right.
You're constantly changing things on latest, and then every once in a while you might want to batch it up into a version. But yeah, so you'd have to rebuild and then rerun. But the only step you have to do on rebuild is it only needs to rerun the copy step, and it will know you don't need to rebuild the Python 3 step.
Yeah. So in the interest of time, there was a lot more to say here, but in the interest of time, a look at maybe what this looks like in a real setting. So City of Santa Monica is working with a number of shared mobility providers. We're using, has anybody heard of MDS? So the mobility data specification is something that LADOT, Santa Monica, and others have been working on to define a data standard for the scooter companies, the bike companies, the shared mobility companies to share operational data with city agencies, essentially regulatory agencies, so we can do our job to regulate. Things like the cap check, things like, you're not allowed to park scooters here, you're not allowed to deploy them in the parks, that kind of thing. So this data standard defines the data that is shared, and the city of Santa Monica created a bunch of processing around this to ingest data from the providers, store it in databases, do some analytics on the data, various things like that. And most of this is packaged up as Docker containers. So, for example, we have a server, and I'll just show you the Docker file. It's a very simple, very single from PostGIS. So a little bit about orchestration here, because it's come up, and Docker Compose has come up a little bit. When you have a lot of different containers, like more than one at a time, Docker Compose is a really nice way to, like you were mentioning, start them all up at once, have them talk to each other. Like I've got a database server over here and a data ingestion script over here. I want the ingestion to happen and stick that data in this database script or in this database container. Well, how does that work? Because these containers are kind of running independently on my machine. Can they talk to each other? Can they pass data back and forth? Well, they can with something called Docker Compose. And typically you're creating a compose file where you're just listing out your different containers. So here we've got one called analytics, another one called client, which provides a PG admin client on top of a PG Postgres server. So here's a container that defines a Postgres server with some different environment variables, ports. So this compose file allows you to, similarly to a Docker file where you're specifying just a single container and what that looks like, the compose file says, here's a bunch of containers and how they relate to each other, the environment that they have, the networks that they use, some storage volumes, the ports that are open, all this kind of stuff. And with these,
Let's stop real quick here.
Yeah.
The storage volumes thing is
Oh.
crucial because you're probably wondering, wait, if all the changes in my container disappear when the container
yes,
drop, what about when I need to persist data, like a database?
right.
So this is how you can say oh, there's this spot this is a linked part of the file system. If I save stuff to MNT data is a common one, that actually represents a part of the root system's file server, and those will be persisted. Typically you want to do this with any sort of database. You say the data directory for the database should be mounted somewhere that persists. So when we save data to the production database, it is actually saved, even if the database container itself disappears at any time.
So like in a VM, right, where you create a mount point and you can share a folder between the VM and your local computer. You can do the same thing with Docker containers. You can say this local directory or this cloud directory or whatever is available inside my container. And when I store data there, when I write data there, it's actually written outside the container, outside the container's file system. So it's persisted when the container goes away. So it's a little bit more setup. We're not going to get a whole lot in that, but it is an important point when you want to get out of kind of the development exploratory mode and you want to take it into production. Now, it's also important to point out, particularly in this case with our MDS pipeline, this server definition here for a Postgres server is what I'm using for development. Okay, so it's my development server, so I can test connecting, I can test writing data, analytics and stuff. But in reality, I'm using AWS and RDS database, right? So I'm not spinning up this Docker container as a Postgres server myself, but because Docker allows us to do like version locking, and I want exactly this version of Postgres with exactly these requirements, I can match up my environment to the real Postgres AWS environment and have the exact same thing locally, so that if I write code, if I'm writing tests or whatever, it should just work exactly the same once it's deployed on AWS.
And this is how a lot of cloud services are packaging up their services that they offer, which is like, it costs a lot of money to run in prod. Like the way you get something that you can work on locally without having to have like a dev instance living in the cloud somewhere is you get a container running whatever is the service that they're packaging for you. Whether it's like an Elasticsearch service or a Kubernetes, not Kubernetes, it's container, Elasticsearch, Redis, Postgres, SQLs, Mongo, whatever it might be. Like typically
Nginx, Apache,
yeah, so that's how you can kind of get your parity between the cloud and your local environment.
Yeah.
Without having to pay for the cloud place.
So our script finally finished, and you can see it did download the data, put it in a data frame, printed out the info here. So there's 104,000 columns. Probably should have picked a smaller data set. 104,000 rows, 20 columns. Here's the names of the columns, their types. Here's the first 5 records. So you can see it's the same thing we are seeing here when we actually looked at the CSV file directly. And if we had a little bit more time, we would talk about maybe, it's not very interesting just printing this information on the console. Ideally, we want to explore the data in a Jupyter notebook. So it's entirely possible to spin up a Jupyter server inside a Docker container that you can get to from your dev machine. So you spin up the container and the server in the container, but then out here on your dev machine, localhost port, whatever that's mapped to that container, then you can see everything that's happening in the Jupyter server, in the web server, database server, whatever it is. So there's ways to connect all this. And a lot of that comes down to something like this compose file where we're exposing different ports. We're passing in environment variables to say this is how you log into this thing.